Do you know what happens to the chemicals you use daily? When you wash off things such as cosmetics down the drain, or when you flush pharmaceuticals down the toilet, they eventually make it to the water that flows underground. When groundwater becomes contaminated, it is difficult and expensive to clean up. But there's still hope. There are methods that are easier and cheaper because they take advantage of natural plant processes. One of these methods is called phytoremediation. With phytoremediation, the site can be cleaned up without digging and hauling soil or pumping groundwater, therefore saving energy. Plants can help clean up many types of contaminants, including metals, pesticides, explosives, and oil. However, they work best where contaminant levels are low because high concentrations may limit plant growth and take too long to clean up. Plants also help prevent wind, rain, and groundwater flow from carrying contaminants away from the site to surrounding areas or deeper underground. But how does it work? Certain plants are able to remove or break down harmful chemicals from the ground when their roots take in water and nutrients from the contaminated soil, sediment, or groundwater. They store the contaminants in the roots, stems, or leaves. Plants then convert them to less harmful chemicals within the plant. The contaminants are converted to vapors which are released into the air. When contaminants stick onto the roots of plants, very small organisms called microbes living in the soil break down the contaminants to less harmful chemicals. This use of microbes to clean up contaminated soil and groundwater is called bioremediation. Again, how does it work? Like phytoremediation, this method works best where contaminant levels are low. Some types of microbes eat and digest contaminants, usually changing them into small amounts of water and harmless gases like carbon dioxide and ethane. The process starts with pumping up some of the groundwater from little wells and then mixing them with organic amendments such as manure compost, biosolid, and municipal soil with the addition of microbes before returning the groundwater back to the wells. Eventually, these microbes diminish contaminants from the groundwater. For bioremediation to be effective, the right temperature, nutrients, and food also must be present. Proper conditions allow the right microbes to grow and multiply and eat more contaminants. If conditions are not right, microbes grow too slowly or die, and contaminants are not cleaned up. However, some contaminants can only be bioremediated in an aerobic environment, one that contains oxygen, while others can only be bioremediated in an anaerobic environment. Phytoremediation and bioremediation both have the advantage of using natural processes to clean up sites. Because it may not require as much equipment, labor, or energy as some may clean up methods, it can be cheaper. Moreover, trees and smaller plants used in phytoremediation help control soil erosion, make a site more attractive, reduce noise, and improve surrounding air quality. These methods are safe and don't really pose any real threats to people at the sites or in the surrounding communities.